Good day everyone. In this video, we're going to do three things. First one is we're going to identify the 5 major parts of a lathe machine and also explain its main purpose or its function. The second one is I'm going to show to you on how to compute the spindle speed that we are going to use in our operation. And lastly, I'm going to perform facing and turning operation using these given dimensions to attain this kind of output. So let's get started. So before we perform the last operation, which is the turning and facing operation, we must first know the 5 major parts of a lathe machine. The first one is the headstock. So this is located at the left end of the machine. So this contains the main spindle mechanism for obtaining various spindle speed. So one of the main purpose of the headstock is to provide different speed and feed. The next part is the feed mechanism. So this is located just below the headstock. So this enables automatic feeding for the tool longitudinally and transversely as needed. The third part of the machine is the carriage. So this provides various movement of the cutting tool to perform various operations on the lathe. The 3 movements are the longitudinal, cross feed, and the angular feed. So the fourth one is the tailstock. So this is located at the right end of the machine. So it can be adjusted along the bedway to suit the length of the workpiece. So one of the primary function of tailstock is to support long workpieces. And lastly is the machine bed. This is the machine bed. So this supports all the mountings of the lathe, such as the tailstock, the carriage, and many more. So the 5 major lathe parts are the headstock, feed mechanism, carriage, tailstock, and machine bed. So that's it. Now, I'm going to show to you on how to compute the spindle speed that we are going to use in our operation. So spindle speed is the number of revolution made by the spindle in 1 minute. So the unit of spindle speed is RPM or revolution per minute. So the formula of spindle speed is 1000 times the cutting speed all over pi times diameter. So the diameter of our raw workpiece is 30 millimeters. So we are given a material which is mild steel. So it has high speed tool which is 30 to 45 meters per minute and the cemented carbide tool which is 90 to 150 meters per minute. So for our cutting speed, we're going to use the 90 meters per minute for cemented carbide tool because carbide is much harder and it has a longer tool life and faster cutting data than high speed tool, and it is 4 to 7 times higher than a high speed tool. So let's input 90. So 1000 times 90, that gives us 90,000. 3.14 times 30, that gives us 94.2. So if we input in our calculator, 90,000 divided by 94.2, that gives us 955.41. 955.41 RPM. So this is now the spindle speed that we are going to use in our facing and turning operation. Now that we are done in identifying the 5 major parts of the lathe machine and also calculating the spindle speed, but before we go on to the last part, which is the operation, we must first study the given output dimensions. But before that, we must first define what is facing and turning operation. Facing means reducing the length of the workpiece, while turning is reducing the diameter of the workpiece. In our Lathe simulation app, we are given a dimension of 100 millimeter in length by 30 millimeter in diameter. In this illustration or in this output, the length is only 80 mm. So there is going to be an excess of 20 mm. So in the later part, we're going to do facing operations to reduce the length of 20. So in our cutting interval will be 2 mm. Why 2 mm? Why not 5, 10 or more? 2 mm because if we go for 10 mm or 5 mm or more, the tendency will be we may damage or break the cutting tool. So we're going to just do 2 mm in real life operations. So the the dimension of 30, we're going to reduce it into 2 millimeters to attain the largest diameter of 28 in our illustration. So we're going to do turning operations with 2 mm with a longitudinal movement of 80 millimeters. To attain a 25 diameter, we're going to do turning operations to reduce 3 mm with a longitudinal movement of 60 millimeters. To attain a 20 millimeter diameter, we're going to reduce up to 5 mm with a longitudinal movement of 40 mm. To attain 15 diameter, we're going to reduce again of 5 millimeter in turning operations and a longitudinal movement of 20 mm. So this is what we're going to do in our simulation. So now, let us start performing our operation, which is the facing and turning operations. So first thing we're going to do to perform the given output dimensions, the first we're going to perform is the turning operation, and followed by the facing operation. But before that, let us check our workpiece dimension and change this diameter into 30, because this is the closest we can get to the given output dimension, which is the 28 diameter, which is the largest diameter, the 28 diameter. And we're going to offset our workpiece to the farthest it can get. And next, we're going to click the toolkit and use the cutting tool number 5 for facing and turning operations. Now let us see if it really is 130 millimeter. The workpiece dimension, is it really 100? Okay, 100 in length. Is it really 30? Let's see. Okay, 100 by 30 millimeter. So next thing we're going to do before we turn on our machine, we're going to change the spindle speed. Based on our calculation, we get a 955 RPM. But let's see what's the closest we can use for our spindle speed. Okay, I think 800 RPM is the closest to 955 based on our calculations. So now let us turn on our machine. And set the angle to top view. Okay. And let us move our carriage close enough to our workpiece. So we're going to use this one, is accelerated, and move the feed forward to the left. I think that's enough. And number 2, change the camera to number 2. Okay, to begin, we are going to turn on the counterclockwise rotation for our spindle speed. Now we're going to calibrate our longitudinal and transversal measurement. Until we hear the cut sound, that is the signal. Okay, that's the 0 right there. Move the workpiece away, and for the transversal movement, let's do a 0.5 in here. And calibrate this until we hear the cutting sound. Okay, that's our 0 right there. So now that we are done calibrating, we are now going to proceed with turning operation. So this workpiece material is 30 diameter, and we're going to reduce it into 28 millimeter based on the given dimension. So we're going to do 2 millimeters in here. And move the feed longitudinal movement up to 80 millimeters, but I'm going to make it 81 for a cleaner cut in facing operation. Okay, let's move now. Okay, let's do it manually. Okay, that's 81 right there. Okay, let us now check if the diameter is 28 millimeter. Okay, good. And as you can see in here, the length, oh my god, I can't move. The length in this area will be 19 millimeter, because we cut a longitudinal movement of 81, so that when we do facing operation, when we do reduce it into 20, we will get a cleaner cut of our workpiece. So now let us proceed again to another turning operation, reducing the diameter of 3, making it 25 millimeter. So we're going to do 2 millimeter first, and then 1 millimeter next, because As what I have said, if we're going to make a big interval, the cutting tool may break or damage. And move it into 60 millimeter in longitudinal movement. Okay, stop, and let's do it manually. Okay, that's 60 right there. I'm going to add 1 more millimeter to make the diameter 25. Okay, that's 3 mm. And stop at 60 millimeter. Okay, let's do it manually. Okay, that's 60 millimeters right there. But before we proceed to another facing operation, turning operation, let us measure again using the vernier caliper if this diameter is now 25. Okay, 25, and let's see if this length is 40 millimeter. Okay, 40 millimeter. Now let us proceed to another facing operation, reducing the diameter of 5 millimeter to make it a 20 diameter. So we're going to do again 2 interval. Okay, turn on. And stop at 40 millimeter in longitudinal movement. Okay, let's do it manually. Okay, that's 40 right there. Another 2 to make it 4. Okay, and stop at 40 millimeter. Okay, that's close. Okay, that's 40 millimeter. And last, 1 more millimeter to make it 5 millimeters all in all. So stop at 40. It's close. Okay. Again, we're going to check it using the vernier caliper, and let's see if the diameter of this one is already 20 millimeter. Okay, good. And the length for this one is 60. Okay, good. We have. So now let's proceed to the last turning operation, and we're going to reduce again to 5 millimeter, making the diameter into 15. So move it 2 millimeters. Turn on. And we're going to stop the longitudinal movement into up to 20. Stop. Okay, that's 20 right there. Add another 2, that makes it 4. And stop again to 20. Okay, next. One last millimeter to make it 15. So 1 millimeter, we're going to reduce 5. So that's 5 right there. And stop at 20. Okay, stop. We're going to move it manually. Okay, that's 20 millimeters right there. Let's see. If this is 80, can't get to 80. Okay, that's 80 right there. And let's see if this is 15 millimeter diameter. Okay, that's it. So this is now what our workpiece looks like. And now we're going to perform the facing operation, reducing this excess right here, which is the 20 millimeter. To do that, we're going to reverse the workpiece material by clicking this one. So okay, so we're going to do 2 millimeters again in interval. Okay. Another 2, that makes it 4. So another 2. Another 2, that makes it 6. Plus 2, that makes it 8. Plus 2, that makes it 10. Plus 2 to make it 12 millimeter. Plus 2 to make it 14. We're almost there, close enough to 20. So our target will be 20 millimeter. plus 2, that makes it 16. Plus 2, that makes it 18 millimeters. And lastly, 2 millimeters, that makes it 20 millimeters in total. So now we are done with facing operation. Let us now check if our length is really 80 millimeters. Okay, good. But before that, for continue, let us rotate again. So let's check the length, 80. The largest diameter, which is 28. Good. The next diameter is 25. Good. The next diameter is 20 millimeter. Good. And the last diameter, the smallest diameter is 15. Good. Now let's check the length. So the next length will be 60 millimeters. Good. Next one will be 40 millimeters. Good. And lastly will be 20 millimeters. Okay, good. So we are done with facing and turning operations. So this is now our output. So before that, let us clean this one. This is where the residues or the pieces of the workpiece material. So we're going to clean that one. And we're going to move the carriage away from our workpiece to prevent it. Okay, switch to camera number 2. So that's it, guys. That's how to perform facing and turning operation. After that, you're just going to save your work here, and then that's it. So thank you for watching.